Hello everybody, and welcome back to another Big Ideas Algebra 2 lesson. Today, we're sort of taking a jump back into Unit 5. As you may recall, Unit 5 was pretty quick. However, this means there was some content that we may have glanced over as opposed to looking at in detail. So one of those lessons is something called the composition of functions. Before we jump into the composition of functions, we should remind ourselves what a function is. If you are given something like f of x, there are two pieces to this. Whatever's inside of the parentheses is your input. It's what you're plugging in. Whatever's on the outside of your parentheses, well, actually it's more like the entire statement f of x, we treat this as your output. So if we have something where it says f of 3, for instance, that tells us that we are plugging in a 3 where x normally is. So f of 3 would be the same as 3. Instead of x, we're putting a 3 plus 2. And 3 times 3 plus 2 is 11. So f of 3, our output, is 11. Same thing if we plugged in a negative 4. We would just be changing what's normally an x into a negative 4. So this would be 3 times negative 4 plus 2. So 3 times negative 4 is negative 12, and negative 12 plus 2 is going to give us negative 10. So f of negative 4 we say is negative 10. With an input of negative 4, we got an output of negative 10. What if we had something else in there? What if we had a smiley face? Well, with this one, instead of an x, we're just replacing it with a smiley face. So this is just going to be 3 times smiley face plus 2. Done. All we did was we replaced an x with a smiley face. And what happens if what you're inputting here is a polynomial? Well, just be careful, because if our input is a plus 2, that means that we are going to change x into the entire statement a plus 2. So instead of 3x, it's 3a plus 2 plus 2. You see how all we're doing is we're plugging in different things for x? That means that f of a plus 2, for instance, would equal, here we can't really solve this and get a number, but we can simplify it. 3 times a is 3a, 3 times 2 is 6. So this is like 3a plus 6 plus 2, which we know can be simplified to 3a plus 8. This last idea of plugging in something a little bit bigger than just a term is the idea behind composition of functions. If we're asked to evaluate f of x plus 4, for instance, what are we inputting into the function? Well, instead of an x, it's an x plus 4. Whenever we're asked to evaluate, it means we actually want to figure out what x plus 4 simplifies to. Well, here's f of x. It's 3x plus 2. Here, we just need to replace x with x plus 4. So this will be 3 times x plus 4 plus 2. And that can be simplified. 3 times x is 3x. 3 times 4 is 12. So we get 3x plus, and 12 plus 2 is 14. Done. That's f of x plus 4. Now, here's where we get to the nitty-gritty of things. Let's say I gave you two functions, f of x, which is the same one as before, and g of x, which is x plus 4. Here, we are asked to evaluate f of g of x. What on earth does that even mean? Well, what it really is, it's saying hey, replace the x with whatever g of x is. In this case, isn't g of x x plus 4? So this is just f of x plus 4. When you see something that says f of g of x, replace your x's with the entire function g of x. So in this case, our input is g of x. F of g of x is the same as if we took f of x, but replaced the x with whatever g of x is supposed to equal. Since g of x equals x plus 4, this is 3x plus 4 plus 2. And it's the same thing that we did. Just like above, the answer is 3x plus 14. So what's the deal with this? The composition of functions is used when you have multiple functions and you are trying to solve simultaneously, for instance. The composition of a function f with g can be written two different ways. You'll see me writing it more often like this, f of g of x. It just means to plug g of x into f of x. Or f of g of x. This little dot here is composed with. F composed with g is the same as saying f with g of x inside of it. So whatever comes second is what you're putting inside of the first function. So let's take a look. Let's say we've got two new functions. G of x is 2x plus 3, and f of x is x squared minus 4. If we want to find f of g of 2, this is asking us to start with f of x, but instead of x, we're going to be plugging in 2x plus 3. So f of g of 2 would be the same as writing out. Notice how f is x squared minus 4. Instead of x, what are we plugging in? We're plugging in this. Instead of x, we have 2x plus 3 squared minus 4. To do 2x plus 3 squared, I recommend think of it more as 2x plus 3 times 2x plus 3 minus 4. We will have to actually FOIL this out, or double distribute. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is another 6x. 3 times 3 is 9. And of course we have the minus 4 at the end. And when we combine like terms, we end up with the following. F of g of x equals 4x squared plus 12x plus 5. But are we searching for f of g of x? Not really. Actually, we're looking for f of g of 2. So notice here, we're asked to plug in a 2 instead of x. So all we need to do from here is plug in a 2 everywhere we see an x. Well, 2 squared is 4, so 4 times 4 is 16. This is 16. 12 times 2 is 24. And 5 is 5. What's 16 plus 24 plus 5? 45. So f of g of 2 is 45. That's one way of solving it. One way of dealing with this composition of functions, when x is not a letter, when it's a number, is to first find f of g of x, then plug in the 2. There is a different way of doing it, but in order to show this, let's actually do g of f of 2. This is like backwards now. Our original function is g of x, so this is what we're starting with, 2x plus 3. But instead of the x, look at what we have in parentheses, f of 2. So we're going to be plugging in f, where x is. Let's do it. However, I want to try something a little bit different. If we're trying to find g of f of 2, What we could do first is we could just start by finding f of 2. So let's look at f of x and see what happens when we change the x into a 2. Well, that'd be 2 squared minus 4. What's 2 squared minus 4? It's 0. So we could say that f of 2 equals 0. So when we're doing g of f of 2, that's just the same as g of 0. To do this, we can just plug in 0 for x. We would get that g of f of 2 equals 2 times that 0 we got, plus 3. And that's just 3. So there are two ways of doing it. There are two processes. The first process is plug in the second function for x in the first function. That's like what we did with the first example. Or solve the inside, then plug into the outside function. Two ways of looking at it. Let's flip the page. So what if we have something that looks like this? Here's what I'd like you to do. I'd like you to actually try out these next couple problems across this page, finding all of these compositions of functions. And there are some weird ones, don't get me wrong. However, I want you to take a couple of minutes and actually go through these. I'm going to be showing you the answers for these, but not the steps through them. So be very careful, take your time, and pause the video. All right, so when we're composing these two functions, here we've got 5 of x to the negative first power. We just plug in g of x for x. Here, we do sort of the opposite. With these examples down here, these ones looked complicated because of the cube roots. However, we remember that a cube root and a cube can cancel out, making these a ton easier. Finally, down here with polynomials, just remember that there are multiple x's that you might have to plug into. So there we go. Finally, on the back side, we have composition of functions with ordered pairs. Ordered pairs, remember, are just a list of inputs and outputs. So for instance, 0, 2 is saying when you have an input of 0, you have an output of 2. So if we're asked to find f of g of 3, we should first find g of 3. Well, when an input is 3, g of 3 equals 0. So since g of 3 equals 0, we know this is just going to be f of 0. What's the value of f when we input 0? Well, according to this point, it's 2. So the answer is 2. What I'd like you to do is I'd like you to try out the rest of these problems on this page. Go through and plug in these different values. My hint for the graph is it's the exact same thing as the points. And if you have any questions, come on in and ask. Thank you, everybody, and good luck.